Welcome. In this video I'm going to show you how you can obtain the Wilcoxon signed rank distribution using Python by using enumeration. I have a separate video which explains a little bit more about the concept of the Wilcoxon signed rank distribution, and the fastest way I think is to simply use my stickpad P library, which actually has a function to do it immediately. Now in this video I'm going to focus if you don't want to use a library and the enumeration method, which simply will mean to go over all the possible options. So if we have n data points, then the ranks can go from 1 to n. And some of these were positive differences, some might have been negative. In total there will be 2 to the power of n different ways to actually split these ranks in positive and negative ones. In each of these possible splits, we can then sum the ranks for the positive and the ranks for the negative differences separately. So let's use as an example n equals 6. And to get all the different possible permutations, let's load that in. I'll actually do a reset of my kernel, edit restart kernel, and restart. So let's say n equals 6. And to get all the different possible ways of all the different combinations, we can use itertools, which is a library that comes with Python usually, and there's a product function. So I made a small little function, or actually copied it from this website, and it simply will have a list of all possible combinations. So we'll load that function in, and then we only have 0 and 1 because either it's positive or it isn't. So I'm going to use this function, all repeat 0 and 1 n times. And then just to show the first 5, there we go. You can now see that it has like the option 0, 0, 0, 0, 0, 0, 0, 1, 1, 0, 1, 1, 1, 0, 0, etc. So for example, 0, 0, 0, 1, 0, 1 would mean that ranks 1, 2, 3, and 5 were from a negative difference. So 1, 2, 3, and 5 were from negative, and these two were from a positive one. Now, in total there should be 2 to the power of n of these different combinations. So let's quickly check 2 to the power of n versus the length of all these different options. And both of them, as you can see, are 64. We don't need them as strings because you can see the quotation signs around them. So what we need to do is we actually need to convert them to numbers. So I'm going to go over all those different ones and then simply actually make them into numbers. And that's done here. Now, we want to sum all those positive ranks. So if this is a 1, then it should have like 0, 1, 2, 3, 4, 5, 5 0, 1, 2, 3, 4, and it should have 4 as the option in there. Sorry, we had 6. My mistake. So it ranges from 1 to 6. So this would be a 5, and this would be a 5 plus a 6, so that should have been 11. So we just create the ranks themselves. First need to load NumPy, and then I can use a range that actually does that for me, so 1 to 6, and we multiply each of them and immediately then sum all the results. So these are the sum of all those, what was it, 64 different combinations. Now, the maximum of these would of course be the number of scores that we have multiplied by the same plus 1 divided over 2, and that in this case should be 21. We can also just take the maximum of these, that gives the same result. Now we can check how often each going from 0 to this 21, each of them actually occurred. That's being done in this little piece of code, and as you can see, so a sum of 0 is only in one different possible combination, a sum of 1 also in one, a sum of 2 in one, a sum of 3 in 2 different ways, etc. The probability itself is actually simply now just taking all of these and divide them by the sum of all of these, and that should be the same as 2 to the power of n, and then we have our probabilities that we were after. We can actually visualize these if you're interested with pyplot, and then you get a nice distribution of the probabilities of the Wilcoxon signed rank. The final check should of course be that all of these together should add up back to 1, and indeed they do. So if I want to know the probability of a t-value of 3, a sum of ranks of 3, I simply look at the 3, which is 0.03125. Lastly, there is no plus 1, so that was for R, and this is Python. So the sum of, if I want to actually have the cumulative one, so a sum of ranks of 3 or less, I can simply sum that array, and then we get 0.078. So that's how you can obtain the Wilcoxon signed rank distribution just by going over all possible combinations. Right, I hope this was helpful, and thank you for watching.